Right, section 2 is all about radicals. Another word for radicals is our square roots. So this is our square roots or cube roots or fourth roots lesson. So the first thing we're going to be looking at is simplifying our roots. Steps to doing that is first we factor anything underneath our root symbol, and then we group them as perfect squares, or as perfect cubes, or perfect fourth powers or fifth powers, or whatever power your root actually is. Everything else that is not a perfect square or a perfect cube or whatever it is, you leave as a remainder. So it'll stay underneath the root symbol. Coefficients, so the things on the outside being multiplied, are all multiplied in front of the radical then. So before we go on, here we have a list of what our perfect squares are. These are what we're looking for whenever we are trying to simplify. It's these numbers in black. I wrote in red here where they came from. 1 is 1 squared, so we call this one a perfect square. 4 is 2 squared, so 4 is a perfect square. 9 is 3 squared, 16 is 4 squared, 25 is 5 squared, and so on. If it helps, I want you to write these off on the side of each of your numbers there, so you remember you have a nice list here of all of these numbers. Each of these numbers in black is the number in red right next to it, squared. Here's a list of perfect cubes then. 1 is 1 times 1 times 1. 8 is 2 times 2 times 2. 27 is 3 times 3 times 3. 64 is 4 times 4 times 4. So these numbers in black are the perfect cubes then. So like 7 cubed means 7 times 7 times 7 is 343. So let's look at some examples of simplifying our radicals. Remember, this sign is the radical symbol. If it's written without any number right here, it just means that it is a square root. Or in a sense, it's like saying our number that's there is a 2. It's kind of a hidden power of 2, which means we're looking for all of the squares in this one, or the powers of 2. So we need to first factor all of these into powers of 2. So 27 we can break down into 9 times 3. X cubed we can break into x to the power of 2 and x to the power of 1. So it's kind of a hidden power of 1 there. If there's nothing written there, it's just a power of 1. 9 is actually the same as saying 3 squared. We know that from our list of squares. So we have the square root of 3 squared times 3 times x squared times x to the first power. We just broke down 27x cubed into these 4 pieces. Now this square root will cancel with any of the square powers, so this one and this one. When we do that though, this piece, the x, and this piece, the 3, need to come out front. So we'd have 3x on the outside, kind of a whole number there, an actual 3x, and then this 3 and this x remain under the square root. So it's the value of 3x times whatever the value of the square root of 3x would be. So these came from finding the square roots. These were the remainders. This would be your final answer then. Let's try another example. This one is going to take a little bit longer because 448 is not necessarily a nice round number. But if we start small, we keep this -5 on the outside, I see that we can divide 4 out of that, and 4 is a perfect square. It's 2 squared. We know the square root of 4. Then we have 4 times 112, and we just simply did that on our calculator, or did the division out, divided this by 4 and got 112. R to the 4th power we broke into r squared and r squared. Now this one we can find the square root of. But 112, we don't know the square root of it. So we want to keep breaking it down until we know for sure that there's nothing else we can get a square root out of. Well, this is an even number because it ends in a 2. So we can definitely divide by 2. Let's see if we can divide by 2 squared. So on your calculator, try 112 divided by 4. And sure enough, that will give you 28. So what we're going to do is split that up into another 4 times 28. Now 28, we know, is two numbers multiplied together. That's another 4 times 7 in this case. And 7 doesn't break down anymore. But 4, 4, and 4 are each perfect squares. Each of them, their square root is 2. So now we've got 3 numbers that are square roots and 2 variables that we can find the square root of. So when we simplify this, square root of 4 is 2, square root of this 4 is 2, square root of this 4 is 2, square root of r squared is r, and square root of this r squared is r. So we move them to the outside, and it's now negative 5 times 2 times 2 times 2 times r times the square root of 7. That square root of 7 has to stay there. Now negative 5 times 2 times 2 times 2 is going to become negative 40. R times r is r squared. So on the outside we have negative 40 r squared, and it's being multiplied by the square root of 7. So this would be your simplified form. Our next two examples use roots that are bigger than square. So this one has a cubic root. So as we break things down, we're looking for cubes. So when we break this piece down, 256 is not a perfect cube, but the first cube that we see is an 8, and we try it out. Sure enough, 256 is divisible by 8. It makes 8 times 32. A to the 6th we can break into a to the 3rd and a to the 3rd. And b squared we can't break into any cubes, so it just stays as b squared. We are looking for perfect cubes because we have a cubic root. So these two are done. This one will not change, will not come out. This 32 is not a perfect cube, but we know that 32 is the same as 8 times 4. So we can break it down even smaller. 8 and 8 are both cubic roots. 4 is not, so 4 will have to remain. The cubic root of 8 is 2. So we can take out 2 from this, 2 from this, a from this, and a from this. The only things that aren't cubic roots under here are the 4 and the b squared. Now again, where I got that from is I just found my perfect cubes. Perfect cube of 8 is 2, because 2 times 2 times 2 is 8. So when I have a cubic root and 8's under here, those can come out and become 2's. So 5 times 2 times 2 times a would simplify down then to 20a squared on the outside times the cubic root of 4b squared. There isn't a cubic root of 4, there isn't a cubic root of b squared, because this is a power of 2, which is smaller than 3, so this is our simplified form. This one has a 4th root, so we need to break it down into things that are to the power of 4. Now this one might be pretty tricky because we don't have a list of our 4th roots. What we're going to do instead is take this 162 and break it down into its prime factorization. So we're going to get it down as small as it'll possibly go. As we look at our variables though, x to the 5 is x to the 4th and x to the 1 power. Remember there's like a hidden 1 there. Y to the 8th is y to the 4th and y to the 4th. Because this is a 4th root, It'll cancel out with this fourth power, this fourth power, and this fourth power. Now before we go anywhere else, we're going to do the prime factorization of 162. So you start with your number 162, and you branch it off into things that it'll multiply by, or divide by. So because it ends in a 2, we know that it's even, and we can divide it by 2. And 2 is a prime number. So that one we underline, that one won't go any smaller. 2 times what would make 162? Well, that would be 81. Now 81 will break into two things. We know 81 is 9 times 9. 9 and 9 are both numbers that can break down. And what do they break down into? 3, 3, 3, and 3. These are all primes then. I'm running out of space there. So what that's saying is 162 is the same as 2 times 3 times 3 times 3 times 3. 3, 3, 3, and 3. This is all the same as just saying 3 to the fourth power. Send this out so it stays there. So we have 2 times 3 to the fourth power times x to the fourth power times x to the first power times y to the fourth times y to the fourth, all underneath this square root. As we simplify then, we're taking all of our fourth roots, like this one, this one, this one, and this one, and each of those get to come out with the 4 of the square root, canceling out the 4 of the power. So we keep our coefficient of 4 on the outside, times 3 times x times y times y. The things that remained under the square root are 2 and x. So this is what it becomes next. Now all we have to do is simplify our pieces down. 4 times 3 is 12, times x times y. Well, that would be a y squared. And underneath our square root, 2 times x is just 2x. So this one would be our final answer then. Operations with radicals. We're going to look at addition and subtraction first. Now in these cases, radicals act like variables with coefficients. We can only add and subtract like radicals. So they have to both say the square root of 5, or the square root of 3, or the cubic root of 2. Those ones you can combine. We always simplify radicals before we try to do operations. So let's look at our first example. We have negative 2 times the square root of 5 minus 3 times the square root of 5. Now notice in both cases, it's the square root of 5, which means we have like terms. You can think of this as like a negative 2x minus 3x. You can combine negative 2x and subtract another 3x from it. So we treat it as though it was, in a sense, like a variable, and we'd say negative 2 minus 3 becomes negative 5. So this is negative 5 times the square root of 5. The square root 5 stays the same. Again, that was kind of like our x, or our variable, and it's just the coefficient in front that changes. In our second example, our root is always the square root of 3, so these will combine. Our coefficients then, we have a negative 1, a positive 3, and a negative 3, or a minus 3. Negative 1 plus 3 minus 3 equals negative 1. So in the end, it's just negative 1 times the square root of 3, or we can just call it negative square root of 3. For our next example, we're going to have to simplify our roots first. These ones we didn't have to because square root of 5 doesn't break down, square root of 3 doesn't break down. But square root of 12 will break down, and the square root of 27 will break down. Those ones will simplify. The square root of 12, well, 12 is 3 times 4. Square root of 27 is 9 times 3. Or should I say the square root of each of those. Now, you could break them up and put two symbols like I have here, or you can put it all under the same square root symbol. So I'm going to show you what that would look like here. Square root of 12 is the same as the square root of 3 times 4. Either way, you're just showing that it's 12 is breaking down into 3 and 4, and we did that because 4 we know the square root of. That would be 2, so that one will simplify. In fact, I'm going to do that right now and just show that square root of 4 is 2, square root of 9 is 3. So when we simplify these, 2 times square root of 3, that's our first part. Oops. And 3 times the square root of 3 is our second part. 2 times 2 is 4. 3 times 3 is 9. So we've got 4 square roots of 3 plus 9 square roots of 3. We still need to combine these because root 3 and root 3. So our coefficients 4 and 9 add up, and we'd get 13 square roots of 3. This would be your final answer. We're going to stop it there for our first video.